Hi, my name is Patrick Desjardins, and in this episode of the auto generation of TypeScript with GraphQL and gRPC, we will dive into improving the mapping from gRPC type to GraphQL, as well as adding gRPC client to connect to the gRPC server instead of using our fake database directly in the resolver. The first part of this episode is to move back on the previous code we created and remove the abomination of code repeating and code at the wrong place. Inside the GraphQL folder, let's open the mapper folder and create a file named mapper.ts. As we remember, we created a mapper.ts inside the gRPC server folder. At that time, we were mapping the generated TypeScript definition type from gRPC into the gRPC class type to perform the gRPC query. Now we are creating a mapper from the gRPC classes type into the generated definition TypeScript type from GraphQL. Once again, we will create a class. As mentioned in the previous video, I do it because it is easier to unit test, in my experience, than having a function directly into a file. When I need to create a mapper, what I usually do is splitting my screen. On one side I have the mapper I want to create, and on the other side I have the definition of the two types. Or in that case, I will open the resolver of the person to copy what we already created previously. The first map is the person from gRPC to GraphQL. As we recall, we are using alias for the person gRPC and one for the GraphQL. We will do the same in the mapping file to stay consistent and to remain clear. So I am copying the import about the types and aliases. Then I am copying the person mapping. I will rename the parameter from age to person gRPC. I will also add people mapping that will take a collection of person and return a collection of person. I like to avoid having looping everywhere because it is the domain of mapping. Having to map a collection in the mapping class makes sense conceptually, but also in terms of testing. We have to test once the mapping of a collection instead of everywhere that we use the collection. Also, we may have some rules like returning null if one mapping fails in some circumstances. Or maybe we want to return an empty array when one of the entities falls. As you can see, the business logic rules can evolve, and when you have a function already in place, it would be a matter of a single place to change instead of many places. Let's fast forward the house mapping until we reach the owner, which is the interesting part. The owner is an interesting case. We do not want to map the whole object because we do not have all the information in the house from the person. We only have the ID. So we need to still set the owner ID, but none of its other fields. Same as we did before, the cast to person is a shortcut because we assume correctly that we will have a resolver that will fetch the complete person and fill up the data at a later stage. There are many patterns we could use, but we will keep it this way for the moment. Let's swap the old mapping code in person resolver for the functions we created. I am adding a variable gRPC GraphQL mapper that I will use in person resolver. We quickly realize that the resolvers are simpler when the mapping code is out of the way. So let's jump to the house resolver. We can already remove the redundant mapping in the house's resolver of the query function. In the house.owner, we can use the person mapping. Here we are managing if the owner was undefined. We're setting by default if no owner that the bank was owning the house. Let's move that logic in the mapping because it is a mapping logic, not a resolving logic. Moving to the mapper class, we need to accept undefined. We copy the logic of the undefined case and use the mapper in the owner resolver. The resolver is a little bit more complex because it fetches the person from the fake database and then map, but still is a two-line operation. So we reached the milestone that we refactor the code to be more reusable, more testable, and more clear. Now let's have our GraphQL server not accessing the fake database directly. In reality, we would communicate with our gRPC server, so let's do it. To do so, we will need to have a gRPC client that connects to the gRPC server. We are in luck because the client has been generated in JavaScript for us as the previous episode on the automatic gRPC server, as well as having the TypeScript type generated for us. The only detail I will add in this episode is a wrapper on top of the client to have functions based on promises. I found it cleaner than using the generated callbacks function generated for us. This is a personal preference, so you can skip that section if you do not want to add that layer of abstraction in your code. The wrapper will be created in the folder gRPC client. That will be a sibling folder of the gRPC server. Let's create two files named client_person.ts and client_house.ts. Then add a class with two clients. The clients are classes generated for us to communicate with the gRPC server. In the classes we created, we add 4 functions. I will fast forward the code creating because that step could be auto-generated further in the future. In short, it wraps using the type in house_pd and person_pd. The client for the person and house is instantiated in the constructor and used in each function to call the server. It is asynchronous. By default, a success or a failure is handled by toCallback function that I am transforming into a promise. This way, we can use async and await in the resolver, which makes the code clear and one-liner. Now, let's set the gRPC client into the services data sources. Inside the GraphQL folder, we have the folder DataSource. Let's add an interface that takes the 2 clients to the services. Back to the GraphQL server.ts, let's remove the service any to the new type we just created. And let's instantiate the 2 clients that connect to the services. At that point, because it is set in the data sources of the Apollo Server Express configuration, we have access inside the resolver. Let's change the resolvers by going into the person resolver and remove the import to the fake database, since we will fetch the data with the code we created. The data source is automatically populated into the context. However, we need to type it. Hence, let's go to the custom context and the data source of type GraphQL custom data sources. Inside the resolver, we can invoke the datasource.personService.listPersons. But we have an issue here. We never created endpoints that return all the people, only one that had a list of IDs or a single ID. We are at a fork here where we have 2 choices. We can create a gRPC endpoint that returns all the people, or we modify the GraphQL query to have an argument that takes a list of IDs. Any modification is technically not too much work, since we have in both cases the generation for us. However, I will go on the GraphQL route, since in real life we wouldn't fetch entirely the whole person or houses. Inside house.graphql, we add an argument to the query of the houses by adding an IDs of type int array. We do the same for the person. Then we use the npm run GraphQL generate ts to have the TypeScript definition of the new query. Back to the resolvers, we can specify the args type with the generated query house args generated for us by the script and query people args. Then we can use the arg to get the people, but we still have TypeScripts complaining. With reason. What we are receiving is a response type, which has all the entities in the gRPC classes that require to access the field with the getter. So you may have guessed what is the next step. Mapping. If we remember in the gRPC mapper, we were converting from the object to the classes. Now we need to go the other way around, from the gRPC class that is in the response to the object. So we have a double mapping, response gRPC to GraphQL. Fortunate to us, we can use the toObject function to perform one of the transformation. In a new mapping function, we can map using the toObject and map using the person mapping function as well. The same is needed for the house, but here we will hit a wall. When fetching from the source, which is the parent, the user, we do not have from the gRPC object information about the houses. A good gRPC response would have contains all the relationship of the person to the house, without having the whole object, just the ID. Then we could use the getListHouses with the list of IDs. So let's quickly change the gRPC message for the person to have the list of houses. In the person.proto, we add repeated google.protobuffer.integer32 value with the name house ID. We generate TypeScript for the gRPC with the npm run gRPC mon. Moving on to the mapper, we map the list with a filter and a map. Back to the resolver, we get the house list ID. Finally, we map the GraphQL mapper to have house in the GraphQL format. That is a lot of mapping, I know. Even with a lot of automation that we are using in this series, we can see that further automation could be used. Nonetheless, everything is strongly typed, which reduces the amount of issues. Let's finish off the resolver by removing the direct access of the house resolver. We need to change the context to the right type to have the autocomplete with the house service. To pass the arguments of the IDs and use the GraphQL mapper of house from response. I'll fast forward the owner, but it is the same logic. Get the owner ID, once fetched, we map. If none, define, we assign the undefined in the mapper, which return the bank person. And we are done. We need to run the gRPC server and the GraphQL server. If you run into an error, you may need to change some imports, since now we are generating the gRPC not directly from the generated folder, but inside the generated server. Also, in the fake.ts, we need to add the house ID list for both our people. In the GraphQL query, we need to pass the house IDs in an argument. Then we can craft our query with the fields we desire. We can create a query that fetches the house and the person that owns the house, and every data coming is from gRPC. That is all for today, but we still have a couple of episodes in front of us. The next one is about data loader. In my perspective, is critical in GraphQL. Without data loader, you access the data like we are doing right now, directly accessing gRPC. But what if you need to query many owners? Maybe you have 100 houses with 100 owners. Currently, we would do one query to fetch the 100 houses by IDs, then one query for each house to get each owner. This problem is called the n+1. One main query, and then one for each child. It can explode if you have many nodes in your graph using the same data. It ends up being costly in terms of request count, but also in terms of speed and resources. In the next episode, we will include the data loader into the resolver and improve the performance of our GraphQL server. Alright, it's a wrap up. So please subscribe and like, and feel free to send me a comment on anything I could improve in the future. See you soon.